Let's talk about something every single software developer has run into. You're trying to build something great, something that lasts. But how do we make sure our code evolves into an architectural masterpiece instead of, a tangled mess? It's the classic story, right? You start a new project, everything's clean, everything's perfect, but then time passes. Little by little, it just decays. Making a simple change becomes a nightmare. Bugs start popping up out of nowhere, and suddenly you're looking at this fragile digital house of cards. So what's the deal? How do we actually stop this from happening? Okay, so let's use a metaphor here. Let's think of our software like we're building a whole city. You just can't build a great city with flimsy materials and no rules. It'll fall apart. You need a solid foundation. In the world of software, we call this foundation clean code. These are our fundamental building codes. And here's a perfect example of what that means in practice. Look at the left side. You've got this lazy code, and it's so unclear that the programmer had to tack on a comment to explain what it does. But now look at the right. The name of the function, user has permission to edit post, is so descriptive, so clear that the comment is totally unnecessary. The code explains itself. That's the dream, right? So these are the red flags, the things we call code smells. Think of them as the shoddy building materials for our city. You've got vague names, functions that are trying to juggle way too many tasks, and magic numbers, these random, mysterious values with zero explanation. Every single one of these weakens our entire structure and makes it that much harder to build on top of later. And this quote, man, it just nails the professional mindset. See, getting your code to just work, that's only the first draft. That's step one. The real craft, the real professionalism, is in going back, refining it, cleaning it up, until it's not just working, but it's something you can actually be proud of. It's a continuous process. Okay, so we've got our quality materials, our building codes. Now what? Well, you can't build a city without blueprints, right? In software, we have these too. They're called design patterns. And they're basically these proven, time-tested, reusable solutions for the kinds of problems we run into all the time when we're building things. Let's kick things off with a total classic, the adapter pattern. The best way to think about it is like one of those universal travel adapters you use on vacation. Your phone charger has one kind of plug, but the wall socket in a different country is totally different. They're incompatible. The adapter just sits right in the middle, acting as a translator so the two can work together. Simple. So in the software world, imagine you have a system that calculates everything in square meters. It's all metric. But now you need to plug in a new part that only understands square feet. What do? You don't rewrite the whole thing. No way. You just build a small adapter that sits between the two and it just seamlessly converts the units. Problem solved, no drama. Now, what happens when you need to build something that's really complex, with tons of different options and configurations? Kind of like ordering a custom-built house. You wouldn't just shout a long, confusing list of requirements at the builder. That would be chaos. And that's exactly what the builder pattern is designed to prevent. It helps us build complex things one simple step at a time. It's just like this. With the builder pattern, we construct our complex software object piece by piece. First, you call a method to lay the foundation, then another one to build the frame, and so on. You go step by step. It keeps the whole process clean, super readable, and it saves you from getting tangled up in a ton of confusing options all at once. All right, deep breath. We've laid our clean foundation with good materials. We've got our blueprints for individual buildings. Now, it's time to zoom way out. We need to look at the master plan for the entire city. This, my friends, is software architecture. And listen, this is so important. A good architecture isn't about picking whatever new framework is trendy this week. At the end of the day, it's an economic decision. The entire goal is to make this system easy to change, easy to maintain, for years to come. That saves a mind-boggling amount of time, money, and sanity down the road. This is the master plan. It's a famous diagram called clean architecture. Right at the very center, the heart of our city, are the entities. These are the core business rules, the fundamental laws that define what our city is all about. In the next ring out, you have the use cases, which are like the specific policies that put those laws into action. Further out, you have things like controllers and presenters, kind of like the city's administrative offices. And then way out on the edge, you have all the decals, the frameworks and drivers, the power plants and roads. And if you remember only one thing from this whole section, let it be this: the dependency rule. It's the golden rule. All it means is that dependencies can only point inwards. So code in an inner circle can know absolutely nothing about code in an outer circle. Your core business logic, the city's constitution, should have no idea whether your database is Oracle or Postgres. It shouldn't care if your user interface is a website or a mobile app. Those are just details on the outside. So what do we mean by details? What are these things that we want to push to the outer edges of our architecture? Well, things like the specific database you're using, the web framework you chose, the user interface, even third-party services. By keeping all this stuff on the periphery, you give yourself the freedom to change your mind later. You can swap out a database or build a totally new UI, all without having to touch the stable, valuable core of your system. This quote just perfectly sums up the entire philosophy. When a developer looks at your project, the structure should scream its purpose. It should scream, I'm a banking system, or I'm an e-commerce platform. It should not scream, I'm a Spring Boot application. The purpose is what's important. The tools you use to build it, those are just implementation details. So I'm going to leave you with this question to think about. Look at the code you work on every day. Is it a thriving metropolis designed to last and adapt over time? Or is it a fragile house of cards where you're scared that one wrong move could bring the whole thing crashing down? Because really, the difference between the two, it's all about architecture.